But always make sure you're approved. If you decide to do that. Okay, so we could actually, the notes aren't gonna be that bad. We'll just kind of do the new stuff, try a few, that'll be it for today. Tomorrow you'll practice it. And then we'll just see what next week looks like when we get there at this point.
Okay.
I guess some teacher just like passed out. It was just like an ambulance cell on that.
See a teacher?
Huh?
Wait.
No, like, I guess it was a teacher that passed
Oh,
out.
really?
And Susan called like 911, which I just saw the ambulance, that's what I thought.
Yeah, I saw
I don't know who it
the,
was.
I saw the nurse with the wheelchair.
Oh, that's so terrible. It's not a good way to start the morning.
Yeah, no.
I
Yeah,
don't know
first,
what it
or no, it's not the first day back.
I'm not sure.
It's not first for you. We've been there a while. Okay.
Maybe cohort B, they just really don't like cohort B.
They were like, oh,
Don't want to go to school.
I've been dreading them coming back.
They were like,
Okay. So hopefully that person's okay. Obviously don't know the details now, but still a good update. So guys, so today you're doing something and you're doing these in your notes. Once again, that worksheet is for tomorrow. It's gonna be kind of based off this though, so, so looking at it. So we're actually starting a new chapter, which I'm kind of excited about because I feel like that solving triangles we did forever. So it's good to move on, do something different. So this chapter is going to be based on something called radians. So radians is just a different way to measure an angle. It's kind of like with measurements, like we use inches and then like the rest of the world uses centimeters. You're measuring the same thing, it's just two different ways to measure it. And you can convert from one way to the other. Same thing, we're used to degrees, but we have this other way to measure angles called radians. And we need radians because there's going to be certain formulas that you plug into that you have to have a radian for. So we just want to get used to kind of going back and forth and then we'll quickly see those formulas. But a lot of today is really just like plugging into something. And I'm going to show you how to use your calculator to do all the reducing and all the other fun stuff. Okay, so the first thing we want to do is we want to be able to convert. So we want to go back and forth I can't talk today, degrees to radians. So once again, we're used to degrees, we can visualize a degree, all that fun stuff, but maybe we'll need a radian for certain things, so we want to be able to go from one to another. So here's how you do it. You start with a degree. You're gonna do the same step every time, so just make a note to yourself what the step is. And when you see these directions, the step is gonna be, we're gonna multiply by, and it's gonna be the same fraction every time, pi over 180. You're probably saying, well, where the heck does that come from? So we're used to the degrees, 180 degrees, and 180 degrees is equal to pi radians. So we use that quick little, not equation, fraction to convert. So here's how you do it. Every time you're just gonna take your degree, you're gonna multiply by pi over 180. If I kind of do that out, that just gives me 30 pi over 180. What happens is your degrees cancel. So that's the main goal. We don't want degrees anymore. I do want to reduce this. So this is where your calculator is going to come in handy. When you're reducing, you don't want to put the pi in the calculator because if you find your pi button, it makes it 3.14 and it's all sorts of ugly. So what I want to do is reduce 30 over 180. So if you're on like the standard TI calculator or one of these calculators, if you have a different one, I can help you. There's a little button, it looks like ABC, there's a little fraction with it. So see if you can find it, or some of them just have like a fraction button, it actually looks like a fraction. So what you're gonna do in this case is hit 30. If you have a fraction button, just hit it. If you have that little ABC button, it looks like this. Hit that. It gives you like a little, kind of looks like what does it look like? Looks like this. That just means over. It's just a fancy thing. And then if you put 180 and press enter, it's going to reduce it for you. So we don't want to do any of the boring reducing in our head here. What that comes out to, it will look like this, 1/6. So that just means 1/6. And then what you're gonna do is just put your pi back with your answer. So we're just reducing the numbers, but we're gonna keep it in terms of pi. So right now, just see if on your calculator you can kind of find those buttons. And we'll practice with it more as we go, but today it's just a lot of reducing. We don't wanna do it in our head, that's the worst. Sorry. So we're gonna make our calculator do most of the work for us, it's just we need to know what to plug in. So if you can't find those buttons or yours is different, because some calculators just are their own thing, just let me know. And I can help you. So basically, every problem from here on out is that exact same step, the exact same reducing, just the original numbers will be a little different. So, same idea. I'm gonna start with a different angle. Let's say my original angle is 135 degrees. And it's gonna say convert from degrees to radians. Every time it says that, I'm gonna multiply by the same thing. I'm gonna multiply by pi over 180. What happens is the degree symbols cancel. I like to rewrite it, you don't have to. So I'm gonna rewrite it as 135 pi over 180. At this point, if you're like, oh, I can just plug that in, just go for it. But then I remember I wanna reduce that. So don't do it in your head. I do more work than you have to. I just grab my calculator, 135, I use that fraction button because it will reduce everything for me. It comes out to 3 over 4. And then just make sure with your answer, you do put that pi back in. That's about as crazy as I get. So the only thing I'm really gonna change is the original angle. All the work from there on out will be the same. So I just want to show you one because sometimes the calculator can be a little annoying with how it gives you answers. So if I said something like 210, and I said convert that to a radian, you would say, okay, I'm going to do my same step. I'm going to multiply by pi over 180. The degrees cancel. I end up with 210 pi over 180. And I just grab my calculator at that point because I don't want to do any of the work. 210 over 180. So it's going to give you an answer that looks like this. That's the answer 1 and 1/6, so that we call that a mixed number, right? So you have the whole number and then you have the fraction. We don't like answers like that. We want improper fractions. So to convert it, the calculator will do it right for you. Depending on your calculator, if you need help, let me know. But if you have that ABC button, you just hit shift or second and then hit that fraction button again, and it will make it into a improper fraction. So hit shift or second, depending on your calculator, and then your fraction button. And then my final answer would be 7 pi, because I'm adding that back in, over 6. So I'm gonna have you try one or two. So as you're trying it, if you're like, I don't know what's going on with my calculator, just let me know, and I will help you out. That's kind of the first thing. So nothing too terrible. And that's what a lot of this chapter is. It's really just plugging in some stuff. That's really what trig is. So once you know the steps, you're kind of just changing the original problem. So can you try these two? Can you convert 18 degrees to a radian? And can you convert 326 degrees to a radian? Main goal is one, you're multiplied by the same thing, it's right there, so that should be hopefully pretty obvious at the current moment. But also, can you just use your calculator to do the reducing and fun stuff like that? So I'll give you a minute before I take attendance. All right, we got Marcus. This one, I'm pretty sure. See? Chris, okay.
Porque algo você porque está de muito bom. Eu não deixo. And I have to wait for my mom to get home. Go home and get dressed. Because I'm literally like, you guys go. I'm just gonna tell, I'm gonna tell her I don't want to. Then tomorrow I'll try to. I feel like again, same thing. Maybe I'll just say, oh yeah, literally see. It's exactly. Cover just work. It was Friday. I think that's why they turned it on. Because they go little things like
Does anyone need calculator help? Oh. So when you're doing like, let's say you're doing 18, so you would do 18 times pi over 180. So you really need to reduce 18 over 180. To do 18, use this button. So that's gonna be your fraction button. So that basically is gonna represent a fraction. So 18 over 180, and you press enter, and now it reduced it for you. So 110, so you would write it as 1 pi over 10.
Okay.
So on that one, yeah, they're all different. Okay, you're gonna use this. So see, it looks like a fraction. So you would put 18, oops, over 180, and when you press enter, it will continue it reduced. So you would write it as 1 pi over 10.
Oh,
Does anyone else need a calculator help? Nice. Okay, so let's check those two. So once again, even I'm doing most of the work on the calculator because it's early and I don't feel like thinking. So main goal, just know what you're multiplying by because we're going to switch it up in a second. We're going to kind of make it a different problem. But so we have that. Once again, if you don't have to rewrite it at this point, I've just been doing it just to kind of show you what I'm reducing. But if you can kind of figure out, I'm just reducing that over that, go for it. But I end up here, once again, I'm just putting 18 over 180 because when you put that pi symbol in, it makes it a decimal and that's all sorts of messy. That comes out to 1 over 10. And then just remember you are putting the pi back with the answer. I'll do that one. And same idea here. The steps are the same, just that original number's changed. The degrees cancel out. I end up with 326 pi over 180. And I'm just going to reduce 326 over 180. Once again, it's going to give you like some weird mixed number. I don't want this. Okay? That means 1 and 73 over 90. So hit shift or hit second and then re-hit your fraction button. And it comes out to 163 over 90. And then once again, we put the pi with the answer. So if you can't figure that one out, just let me know as well. But I don't, mixed numbers are the worst. So just take a moment, have the current moment. Does anyone have questions converting from degrees to radians? All right, now we get to do the fun thing. We get to convert from radians to degrees because we have to go kind of back and forth. You're going to see it's very similar. It's actually a little less work with the whole reducing thing. I'll leave that up for another second in case you're still writing it. So we're going to convert from radians to degrees. So it's going to look similar, but it's not the same. We are going to multiply by 180 over pi. Ooh, we flipped the fraction. Because depending on what you need, you have to kind of cancel things. So I'm going to erase these because now they're just going to confuse me. So in this case, I'm just doing it backwards. I'm starting with a radian. So let's say I start with 2 pi over 3. That's a radian because there's no degree symbol. So that's why I always say like it's important to write a degree symbol with your answer because if you don't write it, technically it's a radian and it gets a little confusing when you can kind of go back and forth. So there's no degree symbol, that's a radian. So we basically took the same fraction, but we flipped it. So we're gonna multiply this by 180 degrees over pi radians. So what happens is the pi's cancel. That's kind of nice. I'm just multiplying straight across, so I'm gonna grab my calculator. 2 times 180 in my numerator, that's 360. We do have a degree symbol now, because that carries over. In the denominator, I just have 3. So 360 divided by 3 would be 120 degrees. There you go. So not even a lot of reducing in this one, it's just kind of dividing your answer out. And then just knowing, oh, if I'm going from radian degrees, what fraction I'm using. But you guys are always going to be able to use notes, so just have it written down somewhere. So you don't have to memorize it. I'm assuming tomorrow in your real life, you're not going to be doing this. So I won't make you memorize anything, that's fine. So I'll try a few more. Once again, the work's always going to be the same, it's just changing that initial thing. Let's do pi over 12. So the reason we do this is because if I was like, hey, sketch that angle, you'd be like, I have no clue what that angle even is. Even though I'm a trig teacher, I'm like, I don't even know where that is. If you ask me to sketch it. But I can do stuff with degrees. So sometimes we might have to convert just to be able to kind of visualize what's happening. So I remind myself, I'm going to multiply by 180 over pi. The pi's cancel. I end up with just 180 in the numerator, and then the denominator is 12, and I just divide that out. And it comes out to 15 degrees. So if I said sketch 15 degrees, you'd be like, oh yeah, I can do that, no problem. So sometimes it's nice to be able to convert back and forth. Let's do one more, and then we'll try one. And then there's just 2 quick little formulas I need to show you. And that's all the stuff you need for tomorrow. That's my shoulder. Let's do one, not crazy, but let's do like, sorry, I'm just trying to, oops, if I was using my calculator correctly, that would be good. Oh. Okay, let's do like a little 64 pi over 45. But remember, it doesn't matter what those are, even if they're weird numbers, it's just like, okay, all my work's done in the calculator, it's just I need to set it up. I'm gonna multiply by 180, remember that's degrees, over pi. The pi's cancel. I'm just gonna kind of see what I got. So the numerator, I'm gonna do 64 times 180. Once again, our calculator is our friend here. 11,520. And the denominator, I just have 45. And if you're doing that work in your calculator, that's fine. I don't necessarily need to see it. I'm just kind of showing you what I'm doing. And then I just divide that out. And it comes out to 256 degrees. Maybe it up. So why don't you try one? And I'll just show you those quick 2 formulas, and then we'll be done. Let's do 7 pi over 8. I just made that up, so it might be this one. So if I said, hey, can you convert that to a degree? Can you see if you can follow the steps you've been doing and try that one? I hate doing attendance now, it's like a 25 seconds. All right, so that shouldn't take too long, because once again, use that calculator to your advantage. So it's just knowing how to set it up. I'm gonna multiply by 180 over pi. Pi's cancel. I'm gonna just go straight across. I'm just gonna do it right on my calculator. So 7 times 180, so I'm just gonna do 7 times 7 times 180. It gives me 1260. I'm not even gonna write it down. I'm just gonna do it right on my calculator, because I'm just gonna divide that by 8. And it comes out to 157.5. Perfectly fine to get a decimal, by the way. And that would be your final. Any problems with that? Oh, isn't that fabulous? Okay, so let me show you the two formulas. Once again, it's just kind of plugging in, so we'll get into more detailed stuff next week. This week was just like kind of getting the rundown of the basics. So let me show them to you and how to plug in. But once again, the actual plugging in is pretty easy, so you're just throwing something in and then putting most of it in your calculator. All right. Okay, so we have two special formulas. One is for arc length. So the arc length, what we're talking about now is basically having a circle. Basically think about like a piece of that circle. So if I take a piece of pie here. When I find the arc length, I'm finding this, how long that kind of outside is. So the thing about triangles is we know how to find the side of a triangle if they're straight, but now one of those sides is curved. So we need a special way to find those lengths. In this case, we have a special formula. The formula is S equals R theta, which means a whole bunch of nothing, because for some reason, I'm sure there's a reason out there somewhere, S represents arc length. I don't know why they use S, just to annoy us. R is going to be the radius. When we're thinking about that, we know a radius is just from the middle. And theta is going to be my angle, but the big thing about this is it has to be in radians. So hence why we're kind of doing it now, because we're talking about radians. But once you can see, it's not the most complicated formula, which is nice. So all we're going to do today is just kind of plug a few things in, and that will be that. So just two problems. Number one, I'm going to say find the arc length. If the radius is 12 centimeters and the angle, so that would be like the angle right here would be theta between the two lines, and the angle is 2 pi over 3. So literally, I don't really need to do much for the setup. I just say, oh, I know R, I'm going to plug it in. I know theta, and it's in radians. Remember, it's in radians because we don't see degree symbol. So I literally just plug those in and I'm done. So I'm going to say S equals R times theta. And I'm just going to use my calculator. In this case, I am going to find my pi button. I just want it as a decimal, just so it's a little bit easier to actually see what's happening. So try to find where your pi button is. I don't even know where mine is on here. Mine's like above something else, so I have to hit the shift button. But I can come help you in a second. Let me tell you what the answer is. Hold on. Sorry, I like to use parentheses just to make sure I'm correct. It should come out to 25.13-ish. So right now in your calculator, press 12. Okay, that's pretty easy. And then do times. To find your pi symbol. So somewhere on your calculator, there's a little symbol for pi. Usually it's above another button, so see if you can find it. If you can't, I can come help you. So I've seen most of these calculators before. And then just do divided by 3. Sometimes if you try to use the fraction button, it gets mad at you, so try it. If you get an error, just do divided by. So I'll give you a second, see if you can actually get that answer. And if you're having you can't find something or you're not getting that, just let me know. Just give me a second, just need to plug it in. Does anyone need calculator help?
Miss Vincent.
Hopefully she's okay.
She's a AP biology teacher.
I think she has physics.
Oh, is she like really tall?
I think so. She's on the second floor.
To be honest, I have no clue who she is. I don't leave my room. I do feel bad.
Like right above.
I don't know why I put this random line there.
Ms. Sherman,
What's up?
when I put this equation into my calculator, I get 8 pi.
Oh, okay, so what happens, you just need to hit something. It's just the calculators. If you ever get something in terms of pi, but we want a decimal, you are going to hit. Oh, okay, you're gonna hit, I think this will work, second, this. Oh, that doesn't work, never mind. Decimal.
Tomorrow we could drop that at my house. Yeah. Cause I can just go for like. And then that takes up like an hour. Yeah. And I'll be working for an hour and a half. Yeah.
Sorry.
Little bit.
I'm gonna have to,
I need a new pen.
or you, for my, you can just leave it like that. I know what, it's the same thing, because I have no clue. Ah, there we go. If you hit this button, it will make something in terms of height.
Oh, okay, thank you.
I knew it was there. So if you want it, you're just going to hit. There's maybe one calculator. Oh, you hit this. So if you got like 8 pi, if you hit this, it'll make it.
Okay.
Yes. That'll make it difficult. So the only other thing that does happen sometimes is you're given information. Find the arc length.
No, you don't.
So if you were given information like that, you would just say, hey, looks, I'm given R and I'm given theta, whoop whoop. But the issue is that theta is in degrees. So all you would have to do is just do a quick converting it over to radians like we did at the beginning of class. So I will do that first. So before I even start my formula, I say, ooh, I don't want a degree here. To convert a degree to a radian, I'm gonna multiply by pi over 180. That gives me 100 pi over 180, which we are going to reduce. So remember, when we're reducing, we will leave it in terms of pi. So I'm just gonna do the 100 over 180 using my nice little fraction button. And it will give me 5 over 9, which I'm gonna put that pi with. So that's what I'm gonna use for my theta. So the big thing with this is you just need to make sure that your angle is in radians. And if it's not, you just have to convert it. But now we can plug in S equals R times theta. I'm using that 5 pi over 9. And then I just throw in my calculator. 3 times 5 pi over 9. Oh, what did I just do? Okay, 3 times 5 pi over 9. And you should get about 5.24-ish. And that would be in inches. So I like that formula because it's like pretty easy. It's only 2 things. You just kind of plug them in and you see what you get. The big thing is if your angle is not in radians, you do have to convert it. So I'll leave that up for a second. And then there's one more quick little formula I'd like to show you just because you need it for tomorrow. Excuse me. And then we'll wrap it up. Oh, today's like a marathon day. All right, the one other formula that we need is for the area of a sector.
Yeah, we did that last week. These people are not doing it. It's helping me.
All right, last one. Okay, so there's my formula. An area of a sector is kind of the same idea as last time. So we have a circle, we're kind of taking a piece. The arc length is finding that like curve. The area of a sector is actually finding the area of the piece of pie, I call it, but piece of whatever. So here, A represents area, that makes sense. R is radius. And theta is my angle, and then once again, it has to be in radians. So hence why we're doing it in the radian chapter. All right, so we'll just do 2 examples, and then we'll wrap it up. Once again, it's just kind of plugging in. So if I said find the area of the sector, if, number right here, the radius is 15 inches, and the angle is pi over 6. So that one I feel good. I'm like, all right, I got the radius, that's fine. The theta is in radians, so I don't need to do anything fancy. I'm literally just plugging it in. So I just use my formula 1/2. So in my calculator, I just do 0.5. R squared, so 15 squared, and then times pi over 6. So that's basically exactly what I'm plugging in. So I just do that in one step and kind of see what I get. So I'm gonna grab my calculator. Remember, we're gonna put the pi in. So we're gonna use our pi symbol in our calculator.
Sure, can you slow down a little bit?
Oh yeah, sure. Yep, I'll take a break after this one. Sorry, I get like into it and I can't stop. So I'm just gonna plug mine in and I'll give you a minute or two. And then if you need help with anything, I'm happy to help you. It does come out to 58 point, I'm just gonna say 58.9, it's 50.9. All right, so let me just go through the steps again as people are kind of catching up. So we have this new formula. So basically you just need to read directions. Am I finding arc length or area? You just kind of pick your formula off of that. So this says area. So we're using this formula. So it's always the same. There's always a 1/2 in front. And then you're gonna do r squared and then multiply it by theta, just making sure it's in radians. So in this case, we were given r, so we were all set there. And theta was in radians, so we were good. So basically I just took those 2 values and plugged them in. So in my calculator, I just do 0.5 or you can do 1/2, same difference. And then times 15 squared, and then times pi over 6. So just make sure you're using that pi symbol, and then that should come out to that. So I'll leave that up for a second. See if you're good, and then we just have one more example after this. Thank you for following today, by the way. I'm trying to do a few extra things since I'm not going to see you tomorrow. I'm so sorry. I have to torture you today. So as of right now, are there any questions on that one? Okay, so last one. Same directions. I'm just getting lazy, so I'm just gonna say find the area. You could probably guess what's gonna happen. We're given the radius, we're gonna say that's 7 centimeters. Oh, and I'm sorry, when you do area, it's inches squared. That's always just your thing. And in this case, my theta is gonna be 220 degrees. So kind of the same thing happened last time. Sometimes it's given in radians and you just kind of plug it in and you're happy. Sometimes you have an extra step if it's in degrees. So we are going to convert this to radians. Because remember, we can only plug radians into that formula. So I'm going to multiply by pi over 180. That gives me 220 pi over 180, and I am gonna reduce that, just to make the numbers a little bit smaller. And then I'm gonna just make sure it's a mixed number. So that would give me 11 pi over 9. So basically, if you're in this chapter and you're plugging into a formula, if it's a degree, you're gonna have to convert it, so just as a heads up. But then from there, it's just throwing what you got into the formula. So A equals 1/2 r squared, and then theta in radians. Once again, we're gonna have to memorize that formula. So just have it handy somewhere written down. You will need it tomorrow. So the more organized your notes are, the easier your life is going to be. And for the last part, I'm just throwing that in my calculator. And I got 94.07. 7. And once again, with area, it's your measurement squared. A marathon of problems today. So thank you for bearing with me. Once again, I had to stick a few extra things in there. So for tomorrow,